Hi everyone, my name is David Poticano, and I am from DSILYTC ID 119. I'm here to discuss the subject DSILYTC regarding the topic hypothesis testing. Uh, First, I'd like to mention what topics within the hypothesis testing we'll discuss. Now, initially, we'll start with the null and alternative hypothesis, followed by what are type 1 and type 2 errors. And lastly, we'll end with the steps for hypothesis testing. So, null and alternative hypothesis. A null hypothesis, or HO, is a statistical hypothesis that contains a statement of equality, such as less than or equal to, or greater than or equal to. While the alternative hypothesis, or HA, is a statement that must be true if HO is false, and contains a statement of inequality such as greater than, not equal to, or less than. Now, when it comes to writing null and alternative hypothesis, we must translate the claim made about the population parameter from a verbal statement to a mathematical statement. So this example is somewhat what I was referring to previously, wherein we have to translate the verbal statement into a mathematical statement. So the example is a manufacturer claims that its rechargeable batteries have an average life of at least 1,000 charges. So as you can see, the null hypothesis that we stated is that, the null hypothesis that we place is that the claim of the manufacturer is correct, wherein the null hypothesis would be mu is greater than or equal to 1,000, wherein that claim of the manufacturer that the average life of their batteries is at least 1,000 charges. So the job of the alternative hypothesis is actually to compete with that, to give the opposite claim. So now we have the claim is incorrect, wherein the manufacturer's claim of the rechargeable batteries being an average life of at least 1,000 charges is incorrect. Whereas the mathematical statement would be mu is equal to less than 1,000. So in this context, mu is the population mean. So let's look into what a type 1 and type 2 error is. So basically, a type 1 error is rejecting HO, or the null hypothesis, when it is true. So since, at the end of the test, one of two decisions will be made. Either you reject the null hypothesis or you fail to reject the null hypothesis. It's always either of the two. So in this case, for a type 1 error is when you reject an HO, when you come up with a null and alternative hypothesis, and you come up with a conclusion wherein you reject HO, or the null hypothesis, when in fact it is actually true. This is a type 1 error. So the probability of making a type 1 error is when the null hypothesis is true as an equality is called the level of significance. So that is what the equality means. That's what's it called, the equality, wherein you make a type 1 error. It's called the level of significance. So applications of hypothesis testing that only control the type 1 error are often called significance tests. So a type 2 error is when you accept HO when in fact it is false. So here again, as I mentioned, wherein you create the null hypothesis and you create an alternative hypothesis, and then you come to the conclusion wherein you accept the null hypothesis, or HO, when in fact it is false. This is basically the definition of a type 2 error, wherein you accept HO when in fact it is false. Now, it is difficult to control for the probability of making a type 2 error, wherein statisticians avoid the risk of making a type 2 error by using do not reject HO and not the phrase accept HO. So when we accept HO, we use the phrase do not reject HO. That's basically it, so that we could avoid the risk of making a type 2 error. Now, I'd like to note that no matter which hypothesis represents the claim, always begin the hypothesis test assuming that the null hypothesis is true. So we always when you make a claim, you always have to assume that the null hypothesis is true. So as you can see, the level of significance. In hypothesis testing, the level of significance is your maximum allowable probability. As I mentioned previously in the slide, it is your maximum allowable probability of making a type 1 error. Now, the level of significance is denoted by alpha, the lower Greek letter. So that is the symbol that we give for the level of significance. Now, for the probability of making a type 2 error, it is denoted by beta, the lowercase Greek letter beta. That's basically it. However, in this scenario, for the hypothesis testing that we'll be discussing, we'll be using alpha, which denotes the level of significance. Now, the commonly used level of significance is alpha is equal to 0.10, alpha is equal to 0.05, and alpha is equal to 0.01. That's a commonly used level of significance when it comes to hypothesis testing. Now, this is another aspect that is really crucial when it comes to hypothesis testing. So we have the p-values. The p-values is the probability, which is computed using the test statistic that measures the support or lack of support provided by the sample for the null hypothesis. There are three types of hypothesis tests, a left, right, or two-tailed test. Now, this is just basically a different term. A left-tailed or right-tailed test is similar to the upper-tailed or lower-tailed test. It's just a different term. And then now we have the two-tailed test as well. So these are the three types of hypothesis tests, which I will expound on later. Now, the type of test depends on the region of the sampling distribution that favors a rejection of the null hypothesis. This region is indicated by the alternative hypothesis. Now, let's discuss what a left-tailed, right-tailed, and two-tailed test is. Now, this is your left-tailed test. Now, if the alternative hypothesis contains the less than inequality symbol, the hypothesis test is a left-tailed test. Now, as you can see in our example, our null hypothesis is stated that mu is greater than or equal to k, while our alternative hypothesis is mu is less than k. So just remember that if the alternative hypothesis contains the less than inequality symbol, this is a left-tailed test. Less than inequality symbol is equal to a left-tailed test. Now remember, this is only on the basis of alternative hypothesis, not the null hypothesis. So just remember that. L is to L, basically. So as you can see, the p-value is the area to the left of the test statistic. Now, what is the test statistic? Basically, the statistic that is compared with the parameter in the null hypothesis is called the test statistic. Now, how do we get the test statistic? Actually, the test statistic is really crucial in part for our steps of hypothesis testing. So it's really crucial to remember this. So in order to get the test statistic, we use the sampling distribution of the standard score, Z. Now, how do we get the standard score Z? Is the formula shown in the right of the slide, basically. So that is your formula in order to get the test statistic, which will be used for the steps for the hypothesis testing. Now, here we have the right field test, somewhat the same thing lang, it's just quite the opposite. So again, if for the right field test, if the alternative hypothesis contains the greater than symbol, the hypothesis test is a right field test. So again, our null hypothesis is mu is less than or equal to k, while our alternative hypothesis is mu is greater than k. So this is a right field test since it contains the greater than symbol. So again, similar thing, the p is the area to the right of the test statistic when it comes to the right field test. A while ago, the p-value is on the left of the test statistic, while for the right field test, the p-value is the area to the right of the test statistic. And this goes with the similar formula lang for the test statistic. So lastly, we have our two-tailed test. Now, our two-tailed test is if the alternative hypothesis contains a not equal to symbol. Just remember that. A two-tailed test is a not equal to symbol. So the hypothesis test is a two-tailed test if it contains that. So that's half your p-value. So as you can see, the p-value is twice the area to the left of the negative test statistic, while the other one for the other side is the p-value is twice the area to the right of the positive test statistic. So there are two values for that. Now we have now before we get into the steps of this, the hypothesis testing, this is also a crucial aspect to the steps. So this is wherein we're making a decision regarding uh, for the conclusion basically. So this is a very crucial concept. So here we have the decision rule based on the p-value, which we will compute for from the test statistic. So since we've got the p-value mentioned in the previous slides, that's how we get the p-value in the test statistic. Now, once we get the p-value, to use a p-value to make a conclusion in a hypothesis test, we compare the p-value with the alpha. So just remember these two, the two decision rules based on the p-value. So number one, if the p-value is less than or equal to the alpha, then we must reject the null hypothesis, or HO. However, if the p-value is greater than alpha, then fail to reject the null hypothesis, or HO. So that's the two decisions that we will make based on the p-value. We can move on to the last part of our segment, which is the steps for hypothesis testing. So there are only a few steps for the hypothesis testing, so I think it'll be easy to take note of these. So I'll try to make it as brief as possible so that you guys could understand. Now, the first step is to identify the null and alternative hypothesis. Now, as mentioned a while ago, it takes practice. It's actually difficult to usually identify which is the null hypothesis and which is the alternative. Sometimes, at different scenarios, it's easier to identify the null hypothesis rather than the alternative. And at some scenarios, the alternative hypothesis is a lot easier to identify than the null. So it really takes a lot of practice when identifying the null and alternative hypothesis in various scenarios. So practice makes perfect. For the step two, specify the level of significance. So step two is basically a given, usually at times for hypothesis testing when it comes to exams. Usually the question would already specify the level of significance, whether it be a 0.10 alpha or the alpha is a 0.05 or a 0.01. So it's already specified for the level of significance. So that's basically a given. Now for the step three, once we have collected the data, the sample data, we then can calculate for the test statistic, taking into consideration the alpha and whether it is a case of one-tailed or two-tailed test. Now, this is the step three. As I mentioned, this is very crucial. That's why we really need to take note of the formula a while ago, because via the formula, we could come up with the p-value. So, as you can see, we have our final steps for the steps for hypothesis testing. As I mentioned, it's just very few. There are only 6 steps all in all. So take note, this is the p-value approach. Now I will be explaining the critical value approach since that's another different approach. But for this presentation, we'll be focusing on the p-value approach. Now, for step 4, we must find the p-value through the test statistic. So we'll be using the formula in order to find the p-value. So after step 4, we'll be moving to step 5, which is we'll be using the decision rule that I mentioned and that we've discussed previously. Now, the question arises, is the p-value less than or equal to the level of significance? So if it's a yes, then we reject HO. Then if it's a no, we fail to reject HO. So that's step 5. Now, the last step, which I mentioned a while ago, is the claim that we'll write, the conclusion or the verbal statement that we'll mention for the conclusion. So step 6 is to write a statement to interpret the decision in the context of the original claim. And that is all for our discussion for today. Thank you so much for listening, and I wish you all good luck for your examinations. And I know that you will do very well. And do your best. Practice again. Practice makes perfect. So good luck and God bless.